Hey, welcome back. So let's start by doing a quick repetition. So we have seen this before. It's our CPU and our RAM, or a little selection of our RAM from address 2000. So we have seen that we can load something into the accumulator and we can store that into memory. So what we haven't talked too much about is the two different ways that we can do things when we're loading into the accumulator. So one way is called immediate, the other is called absolute. So let's start with the absolute. So that's when we write LDA and a hashtag in front of whatever we're loading in. So the hashtag means that this is an actual number. So LDA hashtag 23, that means load the actual number 23. And again, we can use three different numbering systems. So we can do it with hexadecimal, LDA hashtag, and since it's a hexadecimal, we use the dollar sign. So LDA, load the accumulator with 1F, the hexadecimal number 1F. Or we could do it with binary. Load the accumulator with 100100011. So the difference between these two modes of addressing is that here we're loading actual numbers into the accumulator. Here we don't have the hashtag in front of the number. That means that we are loading something from a memory address. So using the hashtag, you say this is an actual number. Whatever comes after the hashtag is an actual number. So load the number 23. Here we don't have the hashtag, so we say load whatever is in memory address 1000 in this case. So let's take a quick look at a demonstration. So here we have basically the same thing. We have our accumulator and there's a 0 in the accumulator, in the X register and the Y register. In the RAM it's almost just zeros, but at address 2002 there's a number 237. Alright, so what if we write some code here? LDA hashtag 73. Load the actual number 73 into the accumulator. Alright, so now the number 73 is inside the accumulator here in the CPU. Alright, so what if we write some more code? STA $2004. What does that mean? It means load whatever is in the accumulator, store whatever is in the accumulator, store that in memory address 2004. So we want to store this number here into address 2004 now. Alright, so like I said, basically that means that we make a copy of whatever's in here at that specified memory address. So then we could write LDA $2002. Now this does not have this hashtag in front of it. So this means load whatever is in this memory address into the accumulator. So in this case that would be 237. So we can load the accumulator with an actual number or something from memory. Okay, so now I think it's time to talk about number systems. So I said in the last video that we would be talking about variables, constants and tables in this episode. I think it's better if we just talk about number systems and get that out of the way. So I just said that we could have three different number systems when programming in assembly language. So what are those three number systems? Well, it's decimal, hexadecimal and binary. Decimal, that's the normal number system that we use every day, from 0 to 9. Just a normal system like that. So a decimal number would look like this. 72, for example, whatever. And remember, since this is 8-bit system, we can use numbers from 0 to 255. Alright, let's write that. From 0 to 255. But the next one, hexadecimal, that's a little more unusual, because this is a 16 unit system. So we have from 0 to 9, but it continues on. But the next value is not 10, it's A. So from 0 through 9, like normal, but then we continue on with A, B, C, D, and F. So that means that we have 16 digits in the hexadecimal system. So that means that we have, let's use a dollar sign, because that's what we do when we use the hexadecimal system. So like the example here, it says $1A. That's okay. If you ever want to do some conversion, there's a great function in your calculator. Both the Windows calculator and a Mac calculator has this function. You just need to set it to programmer. So if I choose 16 here, that means that that's a hexadecimal system, and I write 1A like that, and I click the number 10 system here. That tells us that 1A in hexadecimal is 26 in normal decimal. Alright, so what we, since we're talking about bytes here, 8-bit bytes, let's just write the first, the lowest number that we could have for a byte, which is 00. And it goes to FF. Alright, let's make these a little bigger as well. So this shows us how we could use this when working with bytes. So 1 byte can go from 00 $sign to FF in hexadecimal. So we could talk about this all day probably, but the important part is that you remember that especially when using this during programming, you need to set $sign in front of the hexadecimal number. Alright, let's just look at the next one here, binary. Now the binary number, a binary, that's just ones and zeros. So if you take a look at this number here, we say that it's a binary number when you have a % sign in front of it like this. So the difference, if you're looking at code, the decimal number does not have anything in front of it. The hexadecimal number has a $sign and the binary number has a % sign. So the binary number can go from, let's just set the correct size here. So the binary number could go from 1 0 0 0 0 0 0 0 0 0. So 8 zeros. Alright. So Excel didn't like that. Let me just do that again. So 8 zeros. And it goes all the way up to 8 ones. So the binary number system is something that we need to take a closer look at. We could probably take a closer look at the hexadecimal system as well. But for the hexadecimal system, just try to remember right now that it's a system that goes from 0 to F. So after 9, just continue with A, B, C, D, E, F. So it's a 16 unit system, digit system. But for the binary system, that's a little bit more complicated. So we need to take a look at the binary system in more detail. So let's do that. So we're talking about an 8-bit system. And we talked about 1 byte, that's 8 bits. So one of these ones and zeros is a bit. So what we're looking at right here is 1 byte. 1 byte is made up of 8 bits. And any one of these can be a 1 or a 0. Now, the way this works is that each of these has a value set. Well, it has a value attached to them, you could say. If it's 0, then it's 0. But if we set this one to 1, for example, then we can look down here, and that's the number 1 value. So this number right here would just be 1, because it has number 1 here set for the 1 value. So this is a little hard to explain, but I'm going to try to do my best. If we set a 1 here instead, then that's the number 2 value. And that means that now this number 0000010, that's number 2 in binary. Now we can combine these. So if I set a 1 here as well, then we have a 1 at the 2 place, we have a 1 at the 1's place. So then we just add them together, and that means that this number is the number 3 in binary. So by doing this, we could make any number from 0 to 255. And 255, that's this. If you just have ones all over the place. So if you want to verify that, you could just add each of these numbers together, and you would end up with 255. So, for example, if I just say 1 here, then this number is now 128. And if I set a 1 for every one of these except for the first one, then this number is 127. So 127 plus 128, that's 255. So just remember that each of these bits has a value. 1, 2, 4, 8, 16, 32, 64, 128. Now, this is it might feel a little backwards, but the numbering of these bits goes from the right to the left. So we start here way at the right with what we call bit 0. Remember, for programming, we always start counting from 0, not from a 1. So we have bit 0 here all the way at the right. Then it's bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, and bit 7. So bit 7, so let's say we have a 1 at bit 7. That's the number 128. So again, let's take our calculator up here. And this calculator has a ton of zeros, but let's just focus on these 8 zeros down here. So let's do what I did right here. Let's put a 1 right there. And as you can see, we have 128. And if I put a 1 for all of these zeros, we end up with 255. If I put a 1 at the bit 0 place, there, we get a 1. And if I put a 1 at the bit 1 place, we get 3, because you add these together. So that's basically the binary system. It's a little unusual if you haven't worked with it earlier. So this as well might get some getting used to. But it definitely has its uses. So now you might be wondering, why do we have different number systems? Why can't we just have one number system and be done with it? Well, you can. Actually, this is a lot up to you. Personally, I have seen a lot of people programming in assembly language, and they only use the hexadecimal system. They only use that system, and that's it. And you know what? If you're comfortable with that, then that's fine. Now, for me, I think it's really handy to have separate systems, because they each have their own uses. Now, I use the decimal system. For example, let's say if I want to have a sprite somewhere on the screen. Let's say I want to have a sprite 25 pixels down from the top of the screen. Then I can just write the number 25. It's 25 pixels, 25. That's simple. So 25 in decimal is not 25 in hexadecimal. It's 19. So if I wanted to move the sprite down to 25 pixels down on the screen, and I want to use the hexadecimal system, then I would have to do some conversion in my head. Wait, 25, oh, that's 19 in hexadecimal. Yeah, for me, that just makes things a little harder. So in a case like that, I would use the decimal system. Just remember a straightforward, simple number like 72. So the hexadecimal, I mostly use the hexadecimal system when I work with memory addresses. And that's so simple because when you're working with, let's give an example here. So the Commodore 64 memory, let's do it like that. It goes, as you know, from address 0000. It goes all the way to FFFF. So this is in hexadecimal, and it's just very simple to remember this. It makes it very easy to work with memory addresses because it's divided into 16, and it just works out really well with the 8-bit system that we're working with. So FFFF, that's this number in decimal. So you don't have to go too much into detail with this, but for me it's much cleaner to work with hexadecimal system when working with memory addresses, and that's something that you'll probably get used to quickly. There are also some other cases where I use the hexadecimal system, but let's not worry about that right now. Okay, so I use the decimal when I want to remember a simple number. I use the hexadecimal when I'm working with memory addresses. What about this last one, binary? Well, the binary system definitely has its uses as well. So, what is that? Well, let's take a look at this. So, 1 byte is 8 bits. So, the Commodore 64 RAM is filled with bytes like this. Now, some bytes or some pieces of memory by default we looked at this last time. they are occupied by the Commodore 64 system. And for some special memory addresses, there are bytes that are not set up for storage. So if we quickly just take a look at what we looked at last time, we can see that, for example, address D1000 here, that's occupied by the Commodore 64. So some addresses here in this area are set up so that you don't necessarily store a number in that specified memory address, but you could change the bits at one specific memory address. And by changing only some of the bits in there, you could make different things happen. Now, of course, we're going to look at this in detail later on, but this is one of the uses that I have for binary system. So let's look at a specific memory address. Memory address 1 on the Commodore 64. That's something called the processor port. Now, of course, it's just a memory address on the Commodore 64, so it's 1 byte. But if you take a look at here, by default, this is what that byte is. 0011011111. Alright, what does that mean? Well, here at this great web page, the Commodore 64 memory map, which I will be linking below, you can see what each of the bits does. So by flipping these bits, we can make different things happen. For example, and I mentioned this before as well, we can disable the basic ROM if we don't need to use basic in our program and we want to use that memory space for storage, RAM storage instead. So if we do that, then we could just set the last bit here to 0. So just by changing this last bit here from 1 to 0, just by doing that, we disable basic. So that's one of the uses for the binary system. But also another thing. Let's say that we have, let's make this a little bigger. Let's say that we have a power-up system in our game. So let's say I have a variable called power-ups. Alright, that's my variable. Now, we haven't talked about variables, but a variable is just a memory address. It's just a name for a memory address. In other words, it's just a byte. So, the power-ups, the variable power-ups, it's a byte. That means that we have, let's do it this way. So we have 8 bits, like that. I'm just gonna put them vertically to make this a little easier. So still it's 1 byte. So if my power-ups variable at the start of the game was 0, then we would have 0 for all of these. But I could program a system in my game that gave each of these bits some sort of meaning. So I could say that for each of these bits, it's going to be a power-up to keep track of what power-ups I have in my game. So for the first one, I'm gonna say double jump shoes. For the next one, I'm going to say super shot. For the third one, I'm going to say armor, whatever. So I could program a system that said, okay, I'm gonna put a 1 here if I pick up the double jump shoes. Remember, this is our variable power-ups. So I'm just gonna put a 1 here, and maybe I'll pick up the armor, so that's a 1 here. So in this case, I definitely would not be using a decimal or hexadecimal system, because then I would have to remember, oh wait, 0.0000101. What's that in decimal, or what's that in hexadecimal? That's just, for me, it makes it a lot harder. But if we use binary, we could just set each of the bits as like a switch on or off, because we only need to know, do we have the double jump shoes or not? Do we have the armor or not? So it's just one, or it's just an on or off kind of question. So that's one of the uses I would have for the binary system. So 3 different systems, they each have their own uses, but we need to be conscious of why we're using the different numbering systems, and they each definitely have their own strengths. But for me, I like to use all 3 of them. If you're comfortable with only using the hexadecimal, that's perfectly fine, as long as that's what's best for you. But I definitely recommend trying out using all 3 of them, and we will be doing that in this course. Alright, well, I think that's enough for today. So tomorrow we will be looking at the actual thing we would be looking at today: variables, constants, and some other small things. But hopefully this gave some meaning to the numbering systems for you. So just remember, using decimal number, you don't need to have anything in front of them, except of course if we're loading the actual number 72, we need to use the hashtag, and that goes for the other ones as well. But for the number system itself, we just need to remember a $sign in front of hexadecimal numbers, a % sign in front of binary numbers, and nothing like that for decimal number. Alright, well, that's enough for today, and I'll see you tomorrow. Bye bye.